Hi guys, good morning. Can you hear me?
Yes.
Okay, so let me share this here. Okay, you guys able to see my screen?
Yes.
Okay, so last session we have started with Kubernetes. So we can call it as the advance of Docker. We can go with Kubernetes. So Docker has some disadvantages with the Docker. So even if you want to upgrade your application version, for example, my application image is something like, see, this is my image. So if you want to upgrade the image, what we need to do? We need to stop the container. Again, we need to deploy the new image. So every time when you are going to upgrade your application, we need to stop it or we need to go with a new image. But here we don't have the zero downtime in the Docker. So that's the reason they are going with Kubernetes. And self-healing is not supported in self-healing, load balancers, scaling, zero downtime. So these are not supported from the Docker side. So advanced version, advanced some of the disadvantages which are there in the Docker, so that we can overcome with the Kubernetes. So Kubernetes is so if you are going with a complex architectures, complex applications, then we are be working on the Kubernetes side. So Kubernetes will be called as an orchestration platform. So we can implement the Kubernetes in multiple ways. Okay, so in the real-time scenario, you will be seeing a lot of tool names. So for example, you are working in the AWS, you will be hearing the terminology called EKS, Elastic Kubernetes Service. So with the help of, if you want to implement the Kubernetes setup, you can go with EKS. Same thing if you are going with Azure, we can go with AKS. Same thing if you are going with GCP, GKS. And there are so many alternative tools are available. COPS method, Minikube. Okay. Lot of mechanisms are available, lot of tools which help us to set up the Kubernetes. So in the real-time scenario, it may go with any kind of a terminology, any kind of a setup they will go with. Setup is, we have to set up the a number of ways. Okay. Kubernetes is like orchestral platform. How we are dealing with the Docker Swarm. Same thing here we can deal with the Kubernetes. Docker Swarm alternative is Kubernetes. So Kubernetes is mainly focused on the deployment side. How to deploy your application, how to expose your application internally or externally. So these things only it will be focusing on it. Okay, so mainly focusing on the deploying your application. So in order to deploy your application, so the Kubernetes having the prerequisite is like without Docker, we don't have a Kubernetes. Okay, already you should have knowledge in the Docker, then only we can work with the Kubernetes. But here we are not focusing on the image development. In the Kubernetes, we are not focused on the image creations or image side. We are not going to work it. So we are mainly focusing on the already developed image, how to deploy that image. Okay, so how to scale up. Okay, how to restart automatically if anything goes wrong. Okay, so those type of things we'll be focusing, exposing internally, externally. Okay, so those things will be considered on the Kubernetes side. Okay, so this is the importance of the Kubernetes. So Kubernetes contains a lot of topics are available here. Okay, so any interview question, they will start with the Kubernetes. So the first question they will comes with architecture. What is Kubernetes? Architecture. Okay, so we can create the Kubernetes setup in n number of ways. In the real-time scenario, if they are talking about any number of ways, so we have to go with any kind of a mechanism to set up the Kubernetes. Okay, so first thing is, if you want to work with Kubernetes, we need to understand what exactly the Kubernetes architecture is. Okay, so the Kubernetes architecture when comes here, so here cluster contains group of servers, and we have same cluster means group of servers. It contains master and node machines. For example, if you consider this is my cluster. Okay, so here we have a master machine and we have a node machines. Okay, and master machine, this will be the your master machine. And these are a n number of node machines we can have it. Master machine, node machine, and node machine 1, node machine 2, node machine 3, node machine 4. N number of node machines can have it. So this group of servers, we are going to call it as a cluster. Okay, so inside the master and node machine, we have certain components are there. Okay, so those components are, first component we have API server. So next we have etcd. We have scheduler. Okay, so next node machine also will have the Docker. Okay, so for every node machine, these are the components which are available inside your node machine. Same thing for the master machine also, we have certain components. So API server, etcd, scheduler, control manager, and the node machine will contains kubelet, kubeproxy, and Docker runtime. So these are the naming conventions we should remember, and we should tell in the interview perspective. So when interview asks, can you tell me the Kubernetes architecture? So Kubernetes architecture, it contains master and node machine, and master will have the few components and node have the few components, and master have the components like API server, etcd, scheduler, controller manager. When it comes to the node machine, we have kubelet, kubeproxy, Docker runtime. Okay, so the main primary agents in master and node machines are, the primary agent in the master is API server. And the node machine, the primary agent is kubelet. Primary agent is nothing but, so whenever any request comes to the node machine, any work has to be done, the initiating part will be taken by the agents. So those agents will be in the node machine, it will be the kubelet, and in the master machine, it will be the API server. Okay, so when somebody as a DevOps engineer or Kubernetes administrator, okay, so for Kubernetes, there will be multiple people are working. Either it may be a DevOps engineer or Kubernetes admin. So there will be a separate persons like a Kubernetes admin. A number of persons are there. So if they want to create any kind of a resources, they are going to call either through command based programmatically. So what they will do, so any person as a Kubernetes DevOps engineer or anything, so they are telling that I want to create 2 pods. I want to create a 5 pods. I want to delete the pods. So I want to deploy application. Application in the nothing but, so whatever the application image you are having here. So here in the node machine, generally we have a, this will be the pod. So pod is collection of containers. Whatever the container we are running inside your pod. So if you want to run the container, we should have the image. Okay. So this image, we are providing the details during the execution part, and that image will be creating container. So that container will be your application image. Okay, so there we are going to deliver the image and container. With the help of the image, we are going to create a container. Wherever the container is running, so the collection of the containers. Okay, so that we are going to call in the Kubernetes, it is a pod. It is a logical unit or binding or collection of containers. Okay, so the container will becomes by providing the image details. Okay, so here we can deploy a number of pods. Pod is nothing but it's a container. This container is running. So based upon your image, what image you are passing it is application image or software image. It depends upon you. Okay, so that is the overall architecture of Kubernetes. So now each individual component, how it works, we will go through detailed way. Okay, for example, DevOps engineer or something like Kubernetes admin. So he is telling that I want to deploy one pod here. I want to deploy one container. I want to create a pod. I want to deploy some pod. I want to scale up the pods. I want to scale down the pods. I want to upgrade the image. Okay. So these are the respective action you want to performing it. So any DevOps engineer, Kubernetes admin can be communicate with the master machine or API server. So they are going to use one of the tool called kubectl. Okay, so kubectl is one of the command line tool. So every command in the Kubernetes, so we are going to do with kubectl. So if you want to get the information of anything, if you want to run, if you want to create a pod, so everything we have to interact or we have to perform the command by using kubectl. So by using the kubectl, so one more thing is like always deployments will happen in node machines only, not in master. So master machine only will do controlling part. Okay, so we are not going to deploy any kind of application in the master machine. Always the deployments will happen in your node machines. Okay, so we are not going to deploy anything in the master. Master machine is only for controlling part. Okay, so we are not going to deploy any kind of application in the master. Okay, so in the node machines only we can deploy our application. So whenever the DevOps engineer or the Kubernetes admin tell that, so he is going to interact with kubectl command. So kubectl, I want to deploy one application. Okay, so there are certain commands are there. So if you perform that command, so immediately the request will goes to something like I want to get the list of information of the number of pods. So generally we will type pods. Okay, kubectl get pods will type it. So when you type this kind of information, it will give the list of all pods information. So kubectl, when we are performing this command, get information pods. So immediately when you type this type command in from DevOps engineer or through command line, when you type it, once the Kubernetes setup is done, so when you type kubectl get pods, so the request immediately will goes for API server. Whenever the commands we are typing it, so always the request will goes to your API server. So API server, what it will do? So it will check for the information in the etcd. So etc will be so etcd is like a database for your for your cluster. So whenever you are typing the kubectl get pods, the request will goes to the API server. API server is the main component in the master machine. It will only handle all kind of a request. So before showing the results, so it will check the information from the etcd immediately. So whatever the information we got from the etcd, so if you already have the information, then it will fetch the information from the etcd. If the information is not there, so it will try to store the information in the etcd. etcd will be acting as a database for your cluster. Okay, so all the information related to the cluster will be having in the etcd. Okay, so if you want to fetch the information, so it will look for the etcd. If it is not there, so it will try to store that information in the etcd. And the next thing is, we have the, suppose if you want to create a new pod, so what API server will be there telling, and it will be communicating with the node machine. Okay, and node machine, it will send the request. So I need to create one a pod. Okay, so in order to create a pod, so kubectl, they will run certain command, something like a create pod, pod name, image name. Okay, so something if the user is writing this command, kubectl create pod. I want to create one pod. What is the pod name you want to refer it? For every pod, we should have certain pod name. Okay, so for that one, and hyphen run image equal to image name. Run image, what image you want to write it. It may be application image or it may be software image. So when you want to perform this kind of a command, so immediately the API server will store that information in the etcd and immediately it will send the request to the node machine. So node machine, the primary agent is kubelet. So what this kubelet will do? So it will take that response. Any action which you want to perform in the node machine. So the kubelet is the primary agent. So it will handle that kind of a request. So I got a request that I want to create a new pod. Okay. So immediately it will perform that action inside your node machine and it will share the result that it got created. Immediately it will show that information to the person who executed the command. Okay. So if you are kubelet is mainly responsible for performing any activity in the node machine. If you want to do update, delete any kind of activity, so we will get the request from the API server. So the primary agent in the node machine is kubelet. It will be handling all the requests that is coming from the API server and what action they are asking us. Those actions will be performed by the kubelet and it will share the result to the API server. Okay. Next, we have a Docker runtime. So whatever the images from the images, we are going to create a containers from it. So images and containers part will be handled by the Docker. Okay. So to handle the images and I want to create a container. So those images information, this is a fileless image. We are not going to work on the image creation part. Through Docker, we are going to, already the image has been created. That fileless image only we are going to use for application deployments. And this image part, images and containers. So Docker in each primary agent, in each node machine, Docker will be compulsory it is running. Because we are going to deal with again images and containers only. So if you want to work with images and containers, so Docker container runtime is a compulsory that it comes with your installation. Okay, so no need to do the separate setup. So Docker runtime should be handling your images and containers. And we have a kube proxy is there. So what this kube proxy will be doing? So it will be completely dealing with your networking. Network rules. So when somebody is exposing your application internally or externally, so what are the network rules? What are the ports you want to enable it? Something network related information we are handling it. So the kube proxy will take that will be network related activities will be handled by the one of the component in the node machine is kubeproxy. Okay, so these are components of node machines. Okay, so kubelet, Docker runtime, kubeproxy, and next we have a API server, etcd. API server is the main agent, and this is the primary component in the master machine. Any request comes to the master machine, API server will be taking that request. Okay, etcd is like a database, it will store the information. Now I have one pod is there. I want to upgrade the pod. So I want to increase the scaling the pods. I want to create identical pods. Okay, so in that cases, what this scheduler will do? So the scheduler will be keep on checking whenever any new changes are coming or not. New changes is nothing but, so it will always intimate to the API server that, so you are handled one request, there is some more requests are coming out, like you got the request like they're asking to scale up. So always API scheduler, what it will do? So it will keep on insisting the API server. You got the new request. This request, you got it. New request is getting. You got the upgrade request. You got the delete request. You got the scaling request. So any type of a request that comes to the API server only, but the scheduler will be the backend part. It's keep on running and it is intimating to the API server, making active. Okay, all the incoming requests that are handling by the API server, you need to perform next this activity. You need to perform next this activity. It's keep on telling to the API server and making every time API server active. So this scheduler is a background process. It is running, always waiting for the new request. So something new request is coming. So it will tell to the API server, you got the new request. Perform this new request. Okay. So this control manager is a one type of a component. So it will always check the health checks of your node machine. Health check is nothing but, for example, this node machine is online or not. So if it is offline, something is failure happened with the node machine. So immediately what are the pods which are available in my node machine? Immediately adjust this pods into another node machine. So control manager will be always checking the health checks of your nodes and pods. And it will be, so if anything goes wrong, it will try to adjust the pods. Okay, so every component is interacting with the API server only. Okay, but their role is to do their work and intimate to the API server. Okay, so this is the way we have to deal with the Kubernetes architecture. So this is very, very important one. So every interview question, we will ask the basic question. First question in the Kubernetes is, what is Kubernetes architecture? Okay, why should we go with Kubernetes? So at least we need to tell 2-3 points. What are the disadvantages that are handling able to happen in the Docker? So we need to go with the Kubernetes. What it does? Any doubts? Any questions? Okay, so this is the main architecture of Kubernetes. Okay, so everywhere we have to remember all these components. When it comes to the master means, we need to remember the components. What is kubectl, kubelet, kubeproxy, API server, Docker runtime, control manager, etcd, scheduler. So each and every component we need to remember it. So how they are communicating, what is the role which are playing by the each component, we need to tell it. Okay, at least the component names, at least one line if you tell it, that will be okay. Okay, so this is the one. So next we will go with the setups. Okay, so in order to practice our Kubernetes, okay, so we can write two types of things will be there in the Kubernetes. One through commands. Next thing is object files. Okay, so if you want to create a pod, we can go with two ways. One through commands, another through object files. Okay, so for example, if you want to create a pod, if you type this one, So this is the okay. So this is the way we are going to call it as an object YAML file. So every Kubernetes can be what are the resource you want to create it. So for each resources, we can have the object YAML files are there. So same activity, if you want to create it, we can implement through commands also. So what is the command if you want to create a same container? So what is the image is there? So just we'll go here. So if you want to apply the ports, we can apply the ports also. So this is same thing. We can create a pod by using the commands also. But you should know the information how to create any kind of a resources in the node machine. We can go with two ways. One through command based, another one is object YAML files. Okay, so which object you are working? So that object will be considered under the name called kind. So if you are working on the namespaces, the kind should be namespaces. If you are working on the deployment, so the kind will be deployment. If you are working on the config maps, secrets, replica sets, replication controller, okay, volumes, secrets, any information you are taking. So that means Kubernetes should understand what type of object we are working. So if you're working on the kind as a pod, so okay, we are going to create a pod. So if you're working on the kind as a config maps, so it will says that we are going to work on the config maps. Okay. So wherever the kind information we are writing it, so respect to object, we are trying to create it by using the object YAML file. Okay. So this is the sample one, how to create a pod. Okay. So as per picture, what we are telling, so pod is nothing but collection of containers. So in order to create a container, so we should require the image information. This is image and this image. We are going to create a container from this image. The container name is this one and it is exposed to the port, this one. Okay. So a lot of properties are available with the pod. Okay. So we can create a pod in a number of ways. But in the real-time scenario, they will go with YAML files, object YAML files only they will go with. Okay. So if you want to go with YAML files are commands. But as per the project wise, so most of the cases will go with this YAML files only. So no need to worry about this YAML files. We will get from the internet. So just we need to keep on updating the right side values. So these values will never change. Only we need to be focused on the right side values. So what is your image name? What port they are asking us to expose it? And what is your pod name? What is your image name? What is your container port? Okay. So these information, if we get it, so we can work with the YAML. If you know how to write the YAML file, so they will ask in the interview question, can write a sample YAML file. So at least we need to remember one of the format for anything like API version, what is the kind, metadata, name, under the specification, containers, name, image, ports, and port, container port. Okay. So this, at least we need to remember any one of the sample YAML file. Okay. So in the interview, they will ask us, can you write a sample pod YAML file, pod file? Can you create a deployment? Okay. So they will ask us, can you write a sample YAML file for me, object file. Okay. So we need to remember this scenario, this one. Entire thing we need to remember. At least you can explain it also fine. Okay. So next with the Kubernetes architecture. So in order to set up the Kubernetes architecture, there are multiple ways. Okay. So a lot of tools are available in the market. Okay. COPS method, somebody will tell that COPS method. Minikube. Minikube is used for development purpose. Or if you want to go with the production or anything. So we have two types of things are there. So they will ask in the real-time scenario. So are you using cloud or on premises? So cloud is nothing but, so which type of cloud you are using? So if you are using AK setup or GK setup or EK setup, Elastic Kubernetes setup. Okay. So if you want to go with the Elastic Kubernetes setup, So we have to do the select the servers, what is the master machine configuration, node machine configuration we need to do and set up it. Okay, so we have multiple ways we can do the setup. So another one is on premises. So on premises is nothing but, so we have a client. We are working with a client network or client setup, client systems we are setting the Kubernetes. So those things we are going to call it as on premises. Client related works, client systems, client network. Okay, so those we are going to call it as on premises. Or we are purchasing any license for the online tool. So those things we are also we can consider as on premises. So we are not doing our setup in the cloud, then we will go with on premises setups. Okay, so in the real time scenario, the setup will be done by separate team. So just they will give the cluster details for you. They will tell that cluster information. Okay, so here also we have a multiple environments. So Dev we have a separate setup, SIT we have separate cluster, UAT we have separate cluster, production also we have the separate cluster. Okay, so next thing is, so in order to maintain these clusters, in order to get so much confusion for these setups, so what we can do, we can go with single node also we can go with. Single machine, we can set up the Kubernetes. Okay, so in order to get cluster information, so we can go with single machine also we can do the Kubernetes setup. So this Kubernetes main intention is to understand the concepts and understand the commands. So how to write the object file, how to run it, okay, how to check the resource information, all the things we have to do. And for in the real-time scenario, they are going to talk about one more thing called OpenShift. So OpenShift is also a Red Hat product. So it is alternative to your Kubernetes. So some people will go with Kubernetes. So for every tool, we have a lot of alternative tools are available in also the market. So if you go with OpenShift, so we have to replace the kubectl command with OpenShift. So if you are typing the kubectl get pods here, so when we are working trying to, they will tell that. So we are not using Open Kubernetes, we are using OpenShift. Kubernetes architecture and OpenShift architecture are almost same. So only one difference is routing layer is extra layer will be there in the OpenShift. OpenShift is also one kind of a Red Hat container platform. So it is also help us to deploy your applications. So alternative tool to the Kubernetes. So some companies they go with OpenShift. Okay. So here all the Kubernetes commands we are typing the kubectl get parts. So when it comes to the OpenShift, we have to write like this. OC OpenShift get parts. Okay. So that is the main difference between Kubernetes and OpenShift. Okay, so now we are going to see the setup, how to work with the setup. So in order to work with Kubernetes setup, so minimum we require 4 GB. Minimum 4 GB is required, then only we can work with the Kubernetes. So just we'll go here. We'll go to the EC2 instances, large instance. We'll choose Ubuntu here. Anything version 20, 22 point, anything, it's fine. So here, this is very important in order to do the setup. So we'll go with medium. Minimum 4 GB is required. Keep here. Okay. So in our training, we are using Minikube setup. So this is generally used for development purpose. So the developer will don't have the multiple machines. So in his machine only he can do the setup. Kubernetes activities he can perform it. So that will become a master node machine. Everything will be considered as a single machine. But here we don't see any API server, etc, scheduler. So all the things are the backend part. Directly we will once install it, we will check all the using commands only. So we will work with commands and object YAML files. So when you type the commands in the backend part, it will do and it will show the result for us. Okay. So the main topic in the Kubernetes, first one is namespaces. So next is pods. Then we have a deployment, a replica set, replication controller. So they will ask each and every interview question. Can you tell me the namespaces? What is meant by namespaces in Kubernetes? What are pods? What are deployments? What are replication set? What is replication controller? Difference between replica set versus replication controller. Okay. Stateful set. Next we have volumes. So in these volumes we have PV and PVC. What is persistent volume and persistent volume claim? And we have a config maps. Ninth is secrets. 10th we have a services. Okay, so these are the interview questions they will ask it from the development side. So if you are good at interesting at the admin level thing, so we have some more concepts called role binding, cluster binding. Okay, and some more important topics will be there. So something like liveness and readiness problem. LR, liveness and readiness props. Okay, so what are the interview questions they will ask also? I will tell you this part of training. Okay, so these are the topics they are going to cover from the interview perspective. Okay, so these are the very, very important. At least you should know the definition and how the object YAML file will looks like. So we can take from the internet and we have to run the execution part. Okay, so next we'll go for the installation part. So just we'll check it. Still initializing. Okay, so we got the strategic 2x2. So just we will open it, authenticate it, testing. Just we'll change the colors, appearance. Laundry. Open. Accept. So this system is a Ubuntu. Just we choose as a Ubuntu. Okay. So we are successfully logged into the system. So here, what are the components are there? So we are going to install those components here. So just we'll go with this thing. Okay. These are the installation steps I will guide you. So first we will install it. So update. Once we update, so we have to go with upgrade. Well, have okay. Okay. So next thing is we can clear the script and just we check the history. Okay. So update and upgrade. Two steps we performed it. So next step is we have to go with curl. Okay. So curl we do already it's installed. So next we go with empty transport HTTPs. Just press tab. Okay. So next. So Docker, we are not installing install Docker here. So there is something like updated things will be there. So we have to go with some script here. That script can be downloaded by using the curl. Okay. So that will contain say everything, backgrounding, running part, everything will be there inside that script. Okay. So Docker got installed. So next we have to go and install the ls and we have to go permissions. So next thing is we have a Minikube setup. Download. Whether it is installed or not, we can check by using the Minikube version. So there is a dependency called kubectl also. So we have to go and install the kubectl. Okay. So this step is very important. So Minikube start. So this when you stop the server and when you are starting the server, so every time you need to perform this Minikube start. When you perform this command, what will tell that? So if you have any problem in your installation, it will give error here. Okay, so if your installation goes good, so it will show you that everything is configured. So you can start working on the Kubernetes activities. Okay. So minikube start is the command. So it will shows the entire setup status. Okay. So when you get the information and when you get the output as a 10, so means our setup is done. So if you want to see the cluster information, if you type any command, sorry, kubectl get pods. Okay. So no resources are found in the default namespaces. So when you are performing certain command here, so this is called as a everything we are interacting with the cluster by using the command called kubectl. As per the diagram, so this is the it will take it. So we are doing through everything through kubectl. But this internal part, it will happen internally only. But we will see directly the information from here. Okay, this is the thing. This is the setup. So I will share the steps with you guys. Okay, so if you face any issue in the installation, let me know. Okay, so next session, we will see these topics. What is namespaces, pods, deployments, replica sets. One by one, we'll go with. So how the YAML file looks like, how to execute it, and what is the definition of it. We will go one by one in the next session. Okay. Any doubts, any questions? Anybody have any doubt, questions? No? Okay. So we'll catch up at Monday, guys.